So in this section, we're going to talk about predator-prey interactions. We're going to talk about parasitism. We're going to talk about some ideas behind mimicry as well. So predation is defined as one freestanding organism feeding on parts or all of a second organism. So the example of this would be like an eagle eating a snake would be a great example of predation. Okay? The snake is the predator, or the snake is the prey rather, and the eagle is the predator. Parasitism is a variety of predation in which the predator feeds on prey but does not kill it immediately and may not kill it ever. Parasitism is super interesting. There are lots of really cool parasites. For instance, leeches are a parasite. Another example would be the tarantula hawk, which is this gnarly, super cool wasp that lays its eggs actually inside of tarantulas, and then those eggs parasitize the tarantula until they're born. So here's some parasitism in plants. This is a cool example. You can see these roots are sort of growing around this other tree, and they're eventually going to, they're sucking out its energy, and eventually it will probably die. So predator-prey population sizes move up and down in tight linkage, but it's only one of several factors that control the population of either predators or prey. So let me talk about an example of this. So you have these sloths, and these sloths eat lemmings. Okay, sloths are they're actually kind of a lemming specialist in that they really only eat these lemmings, and you can see here that the sloth population, as the sloth population goes down, or after the sloth population goes down, the lemming population increases, and the sloth population increases as well. Ultimately, the lemming population starts to go down, the sloth population comes with it. But the point that the book makes is that this is only one factor. So there are many other things that feed on lemmings as well. And so as these lemming populations increase, the other things, the non-specialists, go in and start hunting these lemmings, causing their populations to drop. So the point here being is that predator-prey interactions can be tightly linked with one another, but that there are always more factors than just the number of predators out there or just the number of prey available that are driving population sizes. So predator-prey interactions have also spurred the evolution of physical modifications in both predator and prey. So here's a really cool example. If you look at this, if you look at this stick over here, you might see there's some weird-looking branches, but these are in fact just moths. These are just moths that have modified themselves to hide from whatever it is that wants to eat them. Okay, those are cool. Over here, you have a chameleon. I'm not sure if you can see it because it looks just like the tree that it's on. But there's our chameleon friend. There's its left leg. There's its head. It's blending in quite well. Okay, you can see him there. So again, predation leads to these really cool modifications to the physical structures of animals who've just evolved this way over time so that they can avoid predators. And also I should point out that prey evolve as well so that they can ultimately see these guys. And these predator-prey are always in this sort of lockstep arms race. It's called the Red Queen hypothesis, but that's not super important. Just know that predator and prey are moving in to battle each other so that one can try to get an advantage of the other, and the other one's always sort of right behind it. So one form of modification is mimicry. And mimicry is where one species starts to look like another species. Okay? There's Batesian mimicry, which occurs when one species evolves to resemble another species that has protective capability. So Batesian mimicry includes three layers: a mimic, a model, and a dupe. And so you guys should know I study butterflies, and so we're going to look at a picture of a butterfly in a second. But some butterflies happen to be toxic because of the food plant they eat when they're larvae. They are non-palatable to predators. And so what you wind up having happen is you have some butterflies, which are not toxic, evolve to begin to look like the butterflies that are. So the mimic would be the non-toxic butterfly, the model would be the toxic butterfly, and the dupe would be whatever creature it is that's not eating butterflies that it could normally eat. Because it's like, oh, hey, that thing's toxic. I don't want to eat that. And so here's a pretty good example of Batesian mimicry. Here you have on one side a wasp, Okay, obviously nasty characters, they can sting you. On the other side, you have a harmless fly. Okay, not related to one another at all. They cannot interbreed. They are not related, like I said, but they look quite a bit like one another. If you saw this thing, you would probably stay away from it because it's pretty nasty. You also have Malarian mimicry. It's a slightly more complicated idea, but it's when multiple species that have protection against predators come to resemble each other. So that would be like if you had two butterflies that were a little bit toxic, they would evolve to look more and more like one another so that they can have kind of the protection of looking like a toxic